Hey Math 1B in Geometry, I got another video for you over writing linear equations. Given 2 points on a line, really I just wanted to show you the special cases number 4 and 5 at the bottom of this note sheet and see what we can do with the more challenging calculations of 1, 2, and 3. It's mostly the math part for 1, 2, and 3, and then for 4 and 5 it's recognizing, oh, I get a special case. So the first one I wanted to highlight was number 4. 4, 7, 4, 3, 4, negative 3 are the 2 points that we've got going through our line. So if we just do our basic x1, x2, y1, y2, roll through the process of first step, do the m equals y2 minus y1 over x2 minus x1. You get negative 3 minus 7 on top, and then 4 minus 4 on the bottom. The top will be negative 10. The bottom will be 0. Now this always kind of stops people in their tracks. You see negative 10 divided by 0, and it's kind of like, I think I've heard something about that before, where like that's impossible. And if you had a calculator handy, negative 10 divided by 0, it'll usually say something like error, divide by 0 error. You can't do that type error. And then students will kind of be like, so is it negative 10? Is it 0? And here's the answer to it. M is undefined. It's a number that doesn't exist. You can't define it. It's kind of like if somebody gives you a word and it's like, it's not in the dictionary, it doesn't mean anything. It's not defined by anything. That's when you have to take a completely different approach to how you think about these 2 points. So to give us some kind of like step back from this, what I'm going to do is I'm just going to draw a little xy plane and then say, what happens if I plot these 2 points? 1, 2, 3, 4, 4, comma, 1, 2, 3, 4, 5, 6, 7. What if I plotted that point at 4, 7, and then I plotted the point 1, 2, 3, 4 at negative 3? And then I connected the dots and actually looked at the line that we were talking about writing the equation for. Very rough sketch, I know. But do you know what line that represents? It's a vertical line. Yeah, this is a special case. If they both have an x-coordinate of 4, x equals 4 is the special case. So it's weird, and this might take a while for you guys to get comfortable with, but the equation can't be written as y equals mx plus b. The equation of this line is x equals 4, because that's how special case vertical lines are written as equations. So there's number 4. Let's talk about 5 now. It's very similar in that in number 4, the x's were the same. In number 5, the y's are the same. So you got x equals 8 and x equals negative 4. You got y equals negative 2 and y equals negative 2. I'm just curious. Let's graph that one as well. So you got 1, 2, 3, 4, 5, 6, 7, 8, down 2 is the first point. And then 1, 2, 3, 4 to the left, down 2 for the second point. Oh, that's the other type of special case. That's a horizontal line. So if you got a horizontal line, it's not x equals something, it's y equals something. Your answer is y equals negative 2. All right, I'm going to climb back up to the first page. Very slowly. Sorry, that took a while. There's a decimal on number 3. There's a fraction on number 2. There's what seems to be a normal case on number 1. I'll start with what looks to be normal. So you got negative 3, 5, 2, negative 2. x1, x2, y1, y2. It's not a special case in the sense that the x's are the same or the y's are the same. So you're going to get something that looks like y equals mx plus b here. Step 1, you got a fraction with negative 2 minus 5 on top and 2 minus negative 3 on the bottom. This is just addition. So you have 5. This gives you negative 7. I don't know, maybe that's the special case. You got a weird fraction for your slope. Step 2 is where we pick x, y, and use our negative 7/5 m. I'm going to pick the second point, x equals 2, y equals negative 2, and run it through the y equals mx plus b machine. Negative 2 is our y, m is negative 7/5 times 2 plus b. I'm just going to go to the calculator on this one. Negative 7 divided by 5 times 4 ends up giving me negative 5.6. Wait, did I multiply that right? I multiplied that incorrectly. Let me try that again. It's negative 7 divided by 5 times 2. Negative 2.8. So this multiplied together gives me negative 2.8. All right, and I still got to get b by itself, so I just got to add that 2.8 to both sides to get rid of it on the right. You can plug that one through the calculator if you need to as well. Decimals can be tricky when adding sometimes. It ends up being 0.8. So sometimes you'll get an equation where, hey, decimals are in the starting point, fractions that don't reduce are in the slope. So I don't know, your answer's not going to look nice and neat. I'm going to scroll down to the decimal. Sometimes those are less intimidating. All right, you got negative 1.2, negative 3.4, and negative 3 comma 6. Yeah, on step 1, you are going to subtract your y's on top. So it's 6 minus negative 3.4. And you're going to divide that by negative 3 minus negative 1.2. So both of these minus negatives we can call addition. This is just going to be 9.4. And that's going to be divided by, negative 1.8. And again, you can check it on the calculator. Yeah, negative 1.8. If you don't have a calculator that reduces fractions to whatever the smallest whole number divided by whole number is for this, you can multiply the top and bottom by 10 to move the decimal place over on both the top and the bottom. So this would be 94 divided by negative 18. Yeah, and from there, since they're both even, you can divide the top by 2 and the bottom by 2, cutting them in half. You can use the calculator to make that happen too. So when you divide by 2 on the bottom, you get negative 9. On the top, you get Ooh, 47. Okay, so we got 47 divided by negative 9 is our m. Gotta pick an x, gotta pick a y, gotta use the negative 47/9 as our m. Hopefully it's pretty clear to you guys. Like, I don't think I'm going to use a decimal in this case. Maybe use the whole numbers that are given to us to make more sense of this. So use x equals negative 6 and y. Use x equals negative 3 and y equals positive 6 to plug into the y equals mx plus b equation. So 6 is equal to negative 47/9 times negative 3 plus b. Now, here's the thing. I'm okay at this point with you guys just approximating the decimal for this. But do know this. You can put the negative 3 over 1 and then cross-cancel. Divide that by 3, divide that by 3. I'm okay with you using the calculator as well to figure out what this number should be. So it's a negative times a negative, which instantly changes it to a positive. 47 divided by 3, I'm pretty sure is 15 2/3. But you can also like make it a decimal if you want to use the calculator to make that work. I kind of like mixed numbers. Then you'd subtract the 15 2/3 from both sides. And you'll get negative 9 2/3 equals b. So how did I do that? For this calculation, well, I kind of flipped it around. I said, well, really we're taking 15 2/3 minus 6. We just know that the answer is going to be negative because the bigger of the two numbers is negative. So, you could just count, really. You have 15 2/3. Take away 1, 2, 3, 4, 5, 6. The whole number has been reduced by 6. So 15 minus 6 is 9. The fractions were untouched. They're just kind of attached on at the end. So that's your b value. And that's your m value. And here's your final equation. Y equals negative 47/9 x minus 2 and 9 2/3. All right, guys. These were very tough, challenging examples. I'm just trying to get you guys to have a stronger sense of how to do these. And so don't be thinking that I'm going to throw all of these types on sort of like a test or a quiz. This is just the challenging part of the class, is working with these tough examples. All right, that's all I'm going to say. Hope this video was helpful. Thanks for watching.